Everyone got the data file downloaded? Open. Everyone got the solver loaded? By the way, next Tuesday, please bring your textbook. Okay. We're going to use the textbook. So I put it on the Moodle, but in case you don't check it. So next Tuesday, bring your textbook, because we're going to formulate some problems from your textbook. Okay. Okay. So just a very brief review of this problem was. So that's the simple investment problem where we're going to decide how much money to put in each of those bond issues. They have different return and the years to maturity and the risk rating. There are some restrictions on how much you can put in the long term, how much they want to put in the long term ones determined by the years to maturity, and how much they want to put in the low, like what's the maximum they want to put in the high risk ones. So those are like based on percentage. And on Tuesday last week, we look at different ways in defining the decision variables. One is like actual money, dollar amount to put in each bond issue, and the other way is the percentage of money you put in different bond issue. We'll just go with the actual amount of money you're going to put. Okay, so the decision variables are the amount of money you're going to put in each investment. Objective function was to maximize the total, and we said you can either do a yield rate, just like the interest part, or you can also do maximize the total principal plus the yield. And we said we prefer to do the principal plus yield. So when you have the result, you tell your client, okay, this is how much you can get. And then we have some constraints. Okay, so we're going to start from here. So you see, from this data file, the basic informations are here. Okay, so like basically that is table. And what we're going to do is to complete it. If you have your problem statement, you can look at your problem statement. That's a 3.9. And we'll add some of those conditions here. So these are like the basic information there. We're going to add the extra conditions. Okay. Here, so extra. Okay. The first one, they said no more than 25%. So no more than 25% in any investment. This way. Okay. And the number 2 condition. At least the half of money should be in long term. So at least, here we'll do 50%, half. Okay. At least the 50% in long term ones. Long term. And then number 3. No more than 35% in high risk ones. So no more than 35% in high risk ones. Yeah. So that's the 1, 2, 3 constraint we had here. And then we had one more, like the total invested and the non-negativity. Okay, so those are all the information we need. Then we'll start from the decision variables. We know that we're going to decide how much money to put in each of the bond. So I'm going to insert a row here to represent my decision variables. So I put it here because it has the names here. Okay, so represent. Okay, so actual amount to invest. So those are my decision variables. And we have the return, and we said that we're going to calculate the total yield here. We're going to calculate total principal plus yield. So we're going to put like 100% plus those rate. That's our objective function. Then, and we do have the return here. So we'll have like objective function calculated. So that's like 1 plus those return rates, multiply the values, and it kind of take the sum product of this column and this column plus 1. So I'm going to just put it here like a total yield, or total yield. Yeah, I'll just say total. Received. So it's equals to be the sum product of this column and this column. I'm going to put it as total interest, total yield. So it's the sum product of your amount of money to invest and the return. And here I'm going to format this one to currency. Not use accounting, okay? Using accounting will give you some problem. Use the currency. Okay, the format. Did you try it?
What?
Did you try using the accounting format?
No.
Some of you did? Okay. If you try it, it will give you problem when you solve the. Yeah. Okay. Okay. So we have the objective function now. Okay, so that's our objective function, and yeah, if we want, so here's the return. If we want like a total received, we can just put this plus the 750,000. Okay, and then so we'll look at our constraints. We had our decision variables, objective functions, the constraints. The first one is the total invested need to be less than or equal to 750,000. And we didn't have it here, so we're going to add that. This fourth one. Total is 750,000. Oh, just a 0 here. And we're going to put it somewhere. So we know that the first this first constraint is the sum of all of these need to be less than or equal to 750. Okay, and so we want to put it somewhere here. But this space already used. How should we do that? Yes, simple answer. Okay, I'm going to first move this here. Later we may find a better place for it. Okay, but here I'm going to say okay, total invested and the total available. So the total invested represents the left hand side of a constraint. It's the sum. Okay, sum of those. Total invested, representing our first constraint. Sum of all the investments. So that's the left hand side. Okay. I'll shade it. Okay, and the total available is 750,000. And that's my right hand side. So that's the first constraint. Okay. Okay, I'm going to put the sign here. Okay, so represent this as taken care of. I want to check, but I don't have it here, am I? Okay, then we'll look at the second one. Actually, the first. No more than 25% in any investment. And remember when we wrote this constraint, it's like, okay, 1, 2, 3, 4, 5, 6. Each of them need to be less than equal to 25% of the 750. So that means we need to have 6 constraints and then apply to each of them. So when we look at our Excel, it's here. It's like this one need to be less than equal to 20%, 25%, and this one equal less than equal to this one. So we want to probably have another column here to represent the right hand side, though they are the same. Okay, so I'll insert a column here. This will be the right hand side. Oh no, not the entire column, sorry. Okay, so here would be minimum investment. And that's I can put, say, equals to be 25% times this total here. But as we said, we don't want to put numerical values in specific, like in those cells. We want a place to hold this 25%. Okay, and it is here. It's like no more than, so I'm going to just change this one to be, okay, like any investment should be greater than or equal to. So I'm changing this first condition here, okay, greater than or equal to 25%. I'm putting this 25% in its own cell. Moving this one like this. Okay. And the purpose is later, if that requirement changes, I can just come to this cell and change this to 30%, 15%. Okay. So here I can put it equals to be this total value here, multiply this 25%. And you want to fix both of them. So when it's copied, it's the same. Nope. Okay, so now F4. You can just fix both column and row number. Because we don't want either of them move. Okay, then copy it. Okay, just by looking at the value, we can tell it's copied correctly. So I don't need to go click on. Okay, so it is the right one. So that's our minimum investment. That's the right hand side. I'll shade this. Okay, so this one is done. The second one. At least 50% in long-term ones. Okay, so I'll do the same thing again. I want to put this 50% in a single cell. So long-term ones should be greater than or equal to 50%. Okay, so I want my long-term ones to be 50% of this 750,000. Okay, then here we need some thinking to design it. So if we look at back the formula here, this one is A plus D plus M plus S greater than or equal to 50% times this 750,000. Okay, what we can do is, and we choose those ones because they are long-term ones. One way we can do is to simply, like, okay, select a cell, say, you don't have to copy here, okay. So like a long-term, long-term total. Okay, so I can put the long-term total and make it equals to be A plus D, right? A plus D plus M and plus S. So I can do this, okay? But is this a preferred way or not? It's not really, it's hard to track, okay? It's hard to track. You have to go to this, say, okay, which cells were included in this sum here. And what if, say, some of those maturity year change later? For example, this D is 10 now. What if it changes to 9 later? Then we have to go back to change this cell here. And how do we define a long term? It's based on this year to maturity. Okay, so we don't want this way. I'm going to delete this. Instead, we're going to add a column here. Or let me illustrate this first. So we have A, B, E, M, O, and S. So this is all of them. And the long-term one is only A, B, M, right? M and S. So it's kind of like, if we only want to choose A, D, M, S, it's like this times 1 and the other times 0. This times 1, this times 0. It's O times 0, okay? And this times 1. So if you multiply a 0 to those ones that we don't want to choose, then we're not including them in the sum. Okay, and doing this, it's like the benefit of doing this is we can have a column here. Have a 1, 0, 1, 1, 0. And the other column is our decision variables. We basically take the sum product of these two columns, and then we got what we want. Okay, so we're going to use the years to maturity to do that. We'll use a logical function here to say it's if it's a long term, if this value is greater than 9, okay, or greater than or equal to 10, then we return 1, other ones return 0. To make a judgment first to get our coefficients here. If it's a long term, return 1, otherwise return 0. If it's a long term, we want to include it, otherwise we don't want to include it. Okay, so here I'll say long term or not. 1 means yes, 0 means no. And I can copy this all the way down.
What was that?
Okay, so it's a judgment if this value is greater than 9, then return 1, otherwise return 0. Everyone got this part? Okay. Okay, now with this, we can do what I wrote on the board. So, okay. Let's see, where should we use it? Okay, so like a long term. So here are like the long term. So I can put like, okay, long term total. Okay, long term total is the sum product of my decision variables and those 1, 0 coefficients. So I'm trying to calculate the left-hand side of that constraint, only include the long-term ones. Done? Okay. And here we'll say long-term minimal. Okay, so that long-term minimal is this 50% here. Okay, so we calculate it. It's a 50% times your 750. So that's the right-hand side of our constraint. So that's the left-hand side. That's the right-hand side. Okay, then the next one is the risk ones. So I'll do the same. Say high risk ones should be no more than, so less than equal to 35%. Okay, so this one is done. We're looking at the third one now. High risk ones. Now it's the same. The high risk ones are, yes.
Can you go back to your long-term total ones for a second?
This one?
Yeah.
Okay. It's the sum product of this column and the yes, no.
Okay.
Okay. Okay.
Are all those minimum investment values, are they just numerical values, the 187.5s, or is there a formula in those?
This is a formula. That's the 50%. That's the 50% of 750,000.
Okay, that's okay.
That's the
25%?
no. This is a long term.
The minimum investment, Dr. Chen.
You mean this one?
Yep.
Oh, it's the same. They are all the same. So 750 times the 25%.
Yep. Okay.
Okay. Okay. Now we'll do the high risk one now. So we'll follow the same. Determine whether it's high risk or not. High risk using the rating. Okay. And how did they decide whether it's a long risk or not? Let's see if I'm good. Rated lower than very good. So lower than very good. Lower than 2. Lower than very good is high risk. So that's the D, E, and O. O, D, and E. Okay. So it's actually, so if the rating is higher than 2, then it's a high risk. Okay, so again, 1 means yes, and 0 means no. And we'll use the same function again. If this rating is greater than 2, okay, then it is a high risk. Otherwise, it's not. If yes, we'll say 1, otherwise 0. Okay, so if we got it, we'll copy this. So the high risk one, it's a D, E, and O. So that's what we want. Yeah. And we have a place here to put high risk total. And high risk maximum that they can have. The high risk maximum is 35%. Okay, we'll calculate the total first. Sum product of your decision variables column and your high risk ratio column. Coefficient. So here we're trying to see which ones we should include. is the high risk ones. And the high risk maximum is the total multiply is 35%. Okay, shade this. Question?
Could you go back to the long-term minimum?
Long-term minimum. Okay, long-term minimum is the product of 750,000, the total, this one, and the 50%. Okay. Okay, so we got this one taken care of. I'll put a mark. Okay, so and this one I want to make change to this one too. We did it here. I'm going to say total available money. Yes. I'll put 750 here. 750,000. This one we already taken care of. But there are two places where I put it. So I want to make sure when we come to modify the cell, modify the spreadsheet later, this is the only place that we're going to change if we change any information. Okay, so then what I'm going to do is to make this equals to be this value here. So I don't have to go to two places to change it. Okay. Okay, now we're done with the, and we move this, and now we got a place to put it here. I'll put it back. Total return. Okay, so now this spreadsheet design is done. We can go to the solver window. Just going to insert a row here. Okay, we'll go to solver window. Okay, so probably has something, put like a reset all. If you click reset all, it will. Okay, so we'll start from here. The objective, we want to maximize. Okay, want to maximize the objective function, the blue one, by changing all those yellow shaded ones. Those are the decision variables. Okay. And then we're going to take care of all the constraints. So the constraints. Okay, we'll start from here. Any investment should be greater than or equal to 25%. So left hand side, the decision variables greater than or equal to right hand side. Okay, so we're going in this sequence, in this order. And investments, so those ones greater than or equal to that is 25% away. Problem?
Doesn't it say no more than 25%?
Oh, I think so. I think you're right. No more than. Yes, should be less than or equal to. Should be less than or equal to. Thank you. Bonus points. Okay, I'm going to, not to confuse ourselves, I'm going to change this part. Should be less than or equal to. Okay, so then another constraint, the second one. Okay, the long-term ones. So long-term one, we already calculated the total. Long-term total need to be, this time is greater than or equal to, right? Okay, so long-term minimum here, greater than or equal to, and click add another one. The high risk ones need to be less than or equal to the high risk maximum. total investment. So this one now, the sum. Okay, the sum need to be less than equal to 750,000, or you can do equal to. It doesn't matter for this one. Okay. Make them non-negative. Change the algorithm and solve. Okay, find the solution. All constraint and optimality conditions are satisfied. Got a negative means some error. Okay. Then once you're done, you can do some cosmetic work for your spreadsheet. If you have problem, Aaron and I will come take a look. You can do your cosmetic work, like put the borders, put them. So I already posted the homework for this week, and I'm not sure whether we will get the second problem formulated in Excel today. If we cannot finish this one, then I'll move the due date for the next homework, maybe like to the week after next, so we can finish implementing this before you can solve it. Okay, question?
Is there going to be extra credit for this assignment?
Okay. So some of you asked, you did turn in the homework earlier, like yesterday. I said because I didn't announce the extra bonus points for turning in early to the entire class, so I won't do it this homework. But starting from the next one, we can do it. So if you turn in early, you can get the 5% bonus.
Each
Okay.
day or each class period?
Each day, but up to 15%, up to 3 days. Okay. So if you turn in on Tuesday, you get 15%. If you turn in Wednesday, oh, actually 10%. If you turn in on Tuesday, you get 10%. Wednesday 5%. Yeah. Okay.
Can you repeat that actually one more time about percentages and everything?
What's that? So 5% per day earlier. And but that's 15% out of your grade, okay? Like if you get 90, then you get 15% out of 90.
So if we get like a 40%.
What's that?
Now I got it.
You got it, okay. It's a 115%.
Yeah.
Okay. So if you think if I spend one extra day, I'll get it correct 100%, then maybe worth it.
Yeah, so
Okay, yes.
if we get 100% right, oh wait.
Then you get a 115.
Is that 90 points or 90%?
Oh, that's 90 points.
Sorry, I feel bad.
Okay,
If
so
you get
that's
100 points, then you get 115 points in total.
so we can get 115 points per homework.
Yes,
And
yes.
we can get over 100% in homework then?
Okay, so your homework points, that's an equal to 115 points. Okay, and that's the 15%. This 15 points is the bonus, and it's like a 5 points per day. Oh, sorry, 5% per day. So it's like the points you get from your homework multiply the percentage. That's your bonus part. Okay, so let's do the production problem. We just did it Tuesday. If you still have your model. So for that specific problem, we defined the two variables. The production part, like how much to produce each month, and how much to put in inventory at the beginning of each month. And we said the true decision variable is like how much to produce, the number to produce. Okay, and the other one, the inventory, is going to change depending on your decision variable's value, demand, and the ending inventory. So let's put the So that's on the second spreadsheet here. So we have the table. Let me get my paper.
You're not on the board.
Oh, okay. I'm just talking to the screen myself. Okay. Okay, so this one, the table here. Let me find my problem statement. Okay, that's a 3.12. So this one is basically that table you have on your problem statement, okay? And we said we're going to decide how many to produce. Okay, so unit demanded, unit cost. Let's see. I'll just add one row here. Say unit to produce. Unit to produce. Those are my decision variables. Put it here first. And it's like 1, 2, 3, 4, 5, 6 months. Okay, and then we'll look at our. So we said the objective function is the total cost of the production and the beginning inventory. So we do need a place to hold this beginning inventory. Okay. Even though it's not the decision variable, we do need a place to calculate it. And remember we write that relationship. We said the relation is the beginning inventory. So like 0 plus beginning inventory plus production in that month. This is for month 1. Okay. Subtract the demand in month 1 equals to be the ending inventory of month 1. And then you start from here. I1 plus B2 minus B2 is I2 and all the way. So we're going to put in the format. We'll start here. Insert one row here. This will be my beginning inventory. So this one plus the production minus demand. So here will be the beginning inventory. Beginning inventory. I'm going to put those. I'm not going to shade the beginning inventory because it's not going to change. It's not going to be highlighted, defined as decision variables later in the solver. Okay, beginning inventory and the demand. So we do have the unit demand. I'm going to just move this. Move this row here. Unit demand and then the ending inventory. And we know that, okay, I'll wait for you. This one extra column here, I'm going to delete this column B here, okay? In the data, okay. Okay, if you all have this, we're going to put the formula there. We're going to put the formula represent this relationship. This ending inventory equals to be beginning inventory plus units produced in that month, subtract the demand. Beginning inventory plus unit produced, unit demanded, subtract unit demanded. That's our ending inventory. And you can copy this all the way. Click to check. 1, 2, 3. Okay. Everyone done with this part? Okay. And then we're also going to put, we know that the beginning inventory in the first month is 2750. 2750. That's the given, the I0. Oh, the format is not currency, it's just a value number. Put it that number. What about these ones?
Let's just equal the ending inventory of the last month.
Okay. So this is the beginning inventory of the second month, so that's the end inventory of first month, right? So let's just make it equal to here. So the beginning inventory of the second of a month is ending inventory of the previous month, and we can the format. Okay, then we can just copy it all the way.
Because we haven't produced anything yet.
Okay, because we didn't produce anything yet. We only have the demand. Okay. Okay, so that setup help us put the decision variable and the other variable, the inventory in. Okay, and we also kind of already put one of the constraints. That's the linking constraint. We also put this linking constraint there. Okay. Then we're going to put the objective function. Objective function, first part is the production cost. And let's see, where should I put it? That's the unit production cost. So I'll put it here first. I probably will move it later. Total, you know me, right? Okay, total cost. Actually, production cost first. I'm going to separate them. Production cost. Production cost is some product of your unit cost row and your decision variable row. Okay, so we'll calculate the production cost first. Unit produce and the unit production cost. Done? Okay. Okay, so then we also have the inventory cost. So insert another row here. I'm going to calculate the inventory. Inventory. To be consistent, I'll put unit inventory cost. And we know that the inventory cost is 1.5%. Oh, okay. So now I want to put that 1.5% in a specific cell. Okay, I don't want to put it here. I want to refer to it. So I'm going to insert this column here that I asked you to delete because we start from beginning. Okay, put it here 1.5%. So they still look. And I'm going to use, so this one multiply this 1.5%, and I want to fix this 1.5%. So F4. Yeah, you only need to fix the column number, but it doesn't matter if we fix the entire cell. Okay, so then we're going to drag this to calculate the inventory cost. Okay, so that's the production cost. Now we'll calculate the inventory cost. So inventory cost. Because I don't have space to put both of them, I'm going to move this one here. The production cost done and the inventory cost. So the inventory cost is sum product. Actually, we can copy this. We can copy this formula here to calculate the inventory cost, because you see, the production cost is like this unit cost times this one, and when we move it to here, we mainly just need to fix this the decision variable column. So I'm going to put a dollar sign there, just to fix this one here in the production cost, and I'm going to copy it down. So then when it's copied, it's the inventory cost part shift. So the inventory cost is the unit inventory cost, the row, and the unit produce. Some product of these two.
Is it, or is it the end inventory?
Good question. Yes. It's the beginning. Oh, actually, we need to calculate the average inventory. Good question. So we're not really there yet. So we have to create a new row then. We can probably not putting. I don't want to put like a complex formulas inside here. So let's create another row here. So let's put it here. Average inventory. So let's put the average inventory equals to be beginning plus ending plus 2 divided by 2. So we'll calculate the average inventory. Thank you, Cody. So we'll calculate the average inventory, because that's how in your homework problem, the problem said the company calculated the inventory cost using the, I think it's like ending or beginning inventory. Okay, but like in this problem, it's using the average one. So the homework problem is a little different from this one. Yes.
Is there like a way to, okay, so mine is like, I have the formula, right? But it's 1.5 times 240, and it equals 4.
Oh, I think it's probably like the decimal point. This one, use this one. Increase decimal point.
Yeah, I know less. Wait. I think we're good.
You got it now?
No.
It's because it's like negative 10,000, right?
I think you can see, right? But if you click on it.
We divided and added.
Oh,
Yeah, it's right.
And
But really that would be
the
a
format.
problem.
I think your format is better. Okay, so value number.
That doesn't really exist.
Okay. Okay, now we can do.
Yeah.
Okay, you ready to do the inventory cost? Okay, I'm still going to copy this one, but I'm going to just manually move this to here, so I don't need to type the formula. So the inventory cost is the sum product of the inventory unit and the average inventory we just calculated. Yes.
What's your formula for production cost? 'Cause
Production cost is the sum product of your unit production cost and your decision variables. Okay. Once you have that, you can just copy the formula down and click inside the two to move it. Yeah. Yeah, so the inventory cost, I basically copied the production cost, so the unit inventory cost got moved, and I'm going to just move this row here. to the average inventory. So it's the sum product of your unit inventory cost and your average inventory. And you don't need the dollar sign. Doesn't matter here.
What is inventory cost again? Can you just try that again?
Which one?
Inventory cost.
Here, I'm showing this one. The inventory unit cost and your average inventory. Sum product of these two. You don't need the dollar sign. Let me delete it. If I copy it here and I just going to move it here. So that's the inventory cost. Then we'll go calculate the total cost. Total cost. This one's easy now, right? This one plus this one here. So the total cost. And the total cost is our decision, our objective function. Shade this one. Okay, so we have the decision variable's objective function. Now we'll look at the constraints. So for the production, our decision variables, they have a minimum unit that they want to produce. If you remember, that's like half of the maximum capacity. Okay, so they have the capacity, they have the minimum. So we're going to put them in. And if I don't have this table here, I would put like a minimum, maximum around this unit to produce. But there's no space now. I'm going to just put like a minimum production and the maximum production. Oh, actually we do have the maximum production. I'm going to just move this row here. So the maximum production, I'm going to move it here. Replace, okay. And the maximum production are from the book. It's like half of those, so it's like this one divided by 2. I don't want to put this 2 in a separate cell. I think in this case it's fine. It's just like you said the minimum production is half of the maximum production, or we can still do that. Let's be consistent. It's like a 0.5. It's a half of the. So it's this value here, the 0.5 multiply your maximum production. I'm going to fix this 0.5 here. So we're going to copy it. Okay, click. Oh, mine didn't get fixed correct. See, we do need to check. See, oh, I fixed the row number. It's the column number. Copy again. Okay, now it's correct.
And we can also just freeze the entire cell for
Yes, yes. Yeah, we can just click F4, freeze the entire cell. It will be easier actually. Okay, so we have the minimum production, maximum production. Both of those are our right-hand side. Okay, our left-hand side in this case is just the decision variables. So that represents 2 group of constraints. Then the next group is the ending inventory. So they have the requirement on your ending inventory. Maximum is 6,000. The minimum is 1,500. And because like even though they are the same value, because we need 1, 2, 3, 4, like 6 months. Each month we need 1. So we're going to put them in the same format here. or just say like the minimum inventory and the maximum inventory, to put them just in the same format. So the minimum is 1500. That's given. The maximum is 6,000 given. And because I know later I want to do the beginning inventory, like this row less than equal to 6,000, greater than equal to 15000. So I'm going to just copy this. They are the same every month. Okay. Those are all my right hand side. I'm going to shade those. Same here. Okay, so I think that's all the constraints we have. We had this group, we had this group, and we already put this group in when we first define the relationship. Okay, so we got everything. Then we'll just production inventory. Okay, so I'm going to do my move around now. I'm going to move this part to the end to make it look better. Delete those ones. Delete those rows. Okay, so it looks like this. So every month we have beginning inventory, we have unit produced, unit demanded, and the inventory. Also have the average inventory. And I'm going to just move those ones down here. Yeah? My mouse is really difficult to use too. Okay, so here, the production cost. Okay, so that's my setting. So we're going to solver. Okay, reset all. My objective.
Can you hold up a second so you can format our tables like yours?
Oh, okay, sure. Yes.
Do we need left hand?
Do we need the left hand? That's a good question. So like the first group is unit produced. So those are the left hand side of our, like the unit, right? So we won't shade them because they are already decision variables, right? But we can shade the beginning inventories. So according to the problem, like the model we had, like we had these ones, but these ones represent like the ending inventory. Okay, so we can shade the ending inventory row if we think that that will remind us. I didn't shade it in this case because like optimally usually we'll have like okay, the left hand side, then the right hand side, left hand side. But in this case we have those rows all represent the right hand side. Okay. So if we just like if we remind us those are the productions, those are ending inventories, that's fine. But if you feel like okay, maybe we'll shade those ending inventory, we can do that too. We'll shade those ending inventories. That's one of the left hand side, and the other one will be the decision variables. Okay, yeah, so good question. Then we'll go to solver. Objective. Make sure you point to the total cost one, okay? Not the production or inventory, it's the total one. And we want to minimize it. We want to minimize the total cost.
We definitely maximize.
Oh, sorry, did I?
No,
No,
we didn't.
okay. Okay. And then the variables. The variables we want to only select the unit to produce. Ah, my mouse is getting freezing. Let me see if I can use my pen. So it's these ones. I think it has something to do with this recording here. I'm not able to move my mouse. Okay, now.
Hopefully that's what she needs.
Okay. Okay, now the constraints. So constraints, we have only four groups we need to define. Because we have 4 rows shaded dark red. Okay, and another mouse. Okay, so the decision variables, those ones need to be greater than equal to the minimum production. So the first group, your decision variables greater than equal to the minimum production. Okay, add, same, decision variables greater than equal to, less than equal to the maximum. Okay, so that's the second, less than equal to the maximum. Third one, change it to the inventory now. The ending inventory, minimum. Okay, so then greater than equal to the minimum inventory level. Add the fourth one, ending inventory. Now less than equal to maximum. Okay. Okay, so let's see. And earlier, one of you, what's your name? Sorry.
Me?
Yeah. Huh?
Martin.
Martin. Okay, Martin. I remember that. So Martin asked, okay, when we add those constraints, why those becomes like a bound? Okay. So those ones, when we enter them, we didn't select, okay, bound constraint, right? They automatically get categorized as the bound constraint. That's because if you look at those, it's for the decision variables, C8 through H8. So it's for the decision variables. So that represents those 2 groups of constraints set the bounds for your decision variables. In this case, it's one is a lower bound, so the minimum lower bound, and the maximum is the upper bound. It means that your decision variable can only change within this range. Okay. Now let's in our model we also had this constraint, but we don't need to put it in solver. We call those linking constraints. Those linking constraints mainly just link our variables together. Without this group, many of you will forget about this one again in your homework or maybe in the exam. But without those linking constraints, your problem won't solve. Okay? Okay. So we don't need to define them in solver, but we do need them on the model. Okay, so LP. Solve. Okay, find the solution. Satisfied. Okay. So I'm going to put this currency.
I have the same number, it just doesn't show.
I should. It's not gonna make it.
No.
Okay.
Still have one more to go through.
Okay, everyone got this? Good, good. I'm going to put those as currency. Yeah, though. Okay, so I'm just going to do some formatting to make them look good. And the inventory. Average inventory. Oh, I need those ones.
Oh, wait, no, total cost.
Minimum. Okay. This one I'm going to put it in sig border. Okay. Oh, and okay, so that's the production problem. Okay, so that's my. I prefer this way to format. You can do. I'm sure many of you will design it much better than mine. More beautiful. Okay. Yours is?
No.
Can you share? Okay, you will have a chance to share your spreadsheet design. Okay, when we go to the case. Okay, let's do the next one quickly. So if we end up using more minutes, I'll shorten the class time next time. Okay, to make up for it. So let's do this one. So the multi-cash flow problem. That's the investment problem we talk about. And if you, I probably should, yeah, we created the table. Okay, so if you can take your notes, take out your notes from Tuesday, we created a table that represents the way that we're going to create to manage the inflow outflow. So what we're going to do is we're going to put that table in your spreadsheet. So here, this only gives like, okay, which ones are available in which months. So I'm going to put here like what we did in class. So 1, 2, 3, 4. Let's see, A, B, C, D. Okay, I'm going to select 1, 2, 3, 4. Merge. I'll merge those 4 and say those are the cash inflows. So that's the table we created on Tuesday. We're just putting it in Excel. So will be A, B, C, D. Here I'm going to put 1, 2, 3, 4, 5. I'll merge 5 of them. Merge 5 of them to be the cash outflows. This is again from like an investment. So the investment still will be A, B, C, D. A, B, C, D. And then this is a payment. Okay, and then we'll put the months. We'll say months. Here it's like the beginning of the month. I'll put a B here. So beginning, if we count the beginning of the month, we'll count all the way to 7 months, right? 1, 2, 3, 7. Okay, and if we do months, ending of the month. Oh, I don't want this. It automatically change it for me. No. Okay. Here, 1, 2. Okay. It helps when we put the beginning and the ending, so we won't confuse ourselves when we consider those. Okay, now. Okay, so we had the decision variables defined as these ones. At the beginning of month 1, we're going to decide how much we're going to put in. Those represent our A1, B1, C1, D1. Okay. And they also had A2. So if you can look at your model, we have A2, A3, right? Every month we can do a A. So it goes all the way to the beginning month 6. So we have 6 of them. 1, 2, 3, 4, 5, 6. Okay. That's the A1, A3, A5, and 6. Then B, it's every other month. C, I believe it's like 4 months. 1, 2, 3, 4. Okay, this is the 4th one. D, we only have 1. So those are our decision variables. We shaded in this way. And we had some payments. The payment was decided to be due end of the 2nd month, so 250. We can put 1,000 for now. We'll see if we have problem. 2500, 50,000. And at the end we have 300. Okay. So now let's think about how we design our spreadsheet. For example, the first month there's no inflows. It's starting from the 2nd month. Like this one would be this A here multiply 1 plus this 1.8%, representing what we're going to get. But we don't want to do this individually. First, what I'm thinking is we're going to put those yields down here. So represent the A, B, C, D. It's like A, B, C, D. Okay, so we'll put interest rate. And we can just copy this. So click a copy. Okay, click a copy, and here do a transpose paste. Paste special transpose. It will copy this way. Yes, very nice. Okay, so then you copy it here, and then we're going to say 1 plus interest rate, because we do want to. Oh, that's a 1, not. Okay, so 1 plus, we do want the principal and the yield and the interest to count together. So we'll just do 1 plus to all of them. Those are the values that we're going to use to calculate our cash inflows. So now this A2 equals to be this value here, the A1 multiply its rate. Okay, and we want to fix this rate. And want to fix the row number. We'll put the $sign before the row number. So this representing our A1 multiply this yield rate here. Okay, then we can just copy it all the way down, all the way to 7. So the formula is all the same. It's the A here multiply this yield rate. Okay, I'll go slow. So it will be easy to miss. Done? Everyone done? Okay, then we'll do the B. The B, we look at it, it's a B3. So B3 is this B here, multiply the yield rate. And again, fix the row number. Okay. You can still copy this all the way down, and we're going to delete some of them. 1, 2. So delete this one. Oh, actually, it's every other month. Every other month. So it matures every other month. So delete those ones that's inside. Okay. So we had 1, 2, 3. B 3, 5, 6. Yeah, that's correct. Click on the other one, the last one.
Can you go back to the A column and just go to that top one? You're supposed to read that again.
So A is the outflow part, the previous month, multiply the rate.
Okay.
Okay. And B is the same. It's the cash flow outflow in the previous month. Multiply this rate here. And we only have 3 of them. 2, beginning month, 3, 5, and 7. Then we'll have a C. C matures in 4, month 4. Okay. Month 4. So we can look at it here too. So it matures month 4. So it equals to be the C1 multiply the yield rate. And we have let's see, 1, 2. We can again copy this one. I think we have another C mature. Yeah, okay. And just leave the middle too. Oh, I forgot to. So you see, it's very important to check every time you copy it. Check to see if it's copied correctly. I forgot to put the $sign here for this row number. That's the yield rate. I'm going to copy that again. Check. Okay, this time we copied correctly, both sides. Then delete the middle ones. Then the last one is D. D is the easiest. So like in the last month, it's the D1 multiply the rate here. Okay. Now we are set. Then we need just to, so let's just calculate the, we're going to insert a column here. or let's do the, so in our model, we did the other way. We do like cash inflows equals to be cash outflow. Just remember we write the constraint as like this add together need to be equals to be the right hand side. But that means we'll have to calculate a left hand side, insert the column, calculate left hand side, another column here, calculate right hand side, make them equal. Or the other way is to calculate the cash net flow here. So we'll do say cash net flow and make them skip the first row because the first row is our the objective function. Starting from the second month is sum of your cash inflows, right? You can sum this entire row. Many of them will be 0, but we use that formula so we can copy it all the way down. Okay, so the sum of your cash inflows subtract sum of your cash outflows.
Dr. Chen, that,
Yes.
that B column of cash inflows, why is that first 0 down in month?
Because B matures every other month. So every other month you have a B. Say it's like mature every
So
2
where it
months.
starts, okay.
Would,
Okay.
would you want that formula also for the first month too? Because you have
The first month we're going to use it. We'll put the formula, but will be different. This one is our decision variable. Sorry, the objective function. Okay, so we'll do that later. Because in the decision variable objective function, we said we want to minimize total cash outflow. So that's different from those one. We just want to make sure the cash net flow is greater than equal to 0. Okay. So that's so the cash net flow starting from the second row. Okay. So it's the sum of the inflows subtract the sum of outflows. We want them to be greater than equal to 0. So we'll copy this all the way. And we're going to shade those ones. As the left hand side, we'll just say these ones all need to be greater than equal to 0. Okay. Yes, now then back to this first row, we'll simply do a sum of our cash outflows. That's our objective function. We want to minimize the total out-of-pocket money today. So that's the sum of the outflows. And then we'll just shade it in blue. Okay. I think we're done. Any questions here? Before we go to solver? Yes?
Can you go back to the formula under the blue?
This one?
Right underneath it.
Oh, underneath? It's the sum of your inflows. Subtract the sum of your outflows. Okay. Okay, now we can go to solver. Ready? Okay. Our objective. Minimize this total out-of-pocket money. This blue cell. We want to minimize it. Click OK. Now I want to talk about this decision variable part. So in this one, we know only those yellow shaded ones are our decision variables. So you don't have to follow now, okay? One way to do it is to click this one. I think you probably click like a, yeah, so if you click control and you can click, you can select all the different ones, so it will add for you. Okay, if you click control and then select different cells, because they are not like a block, there's some cells that we're going to skip. So that's one way to do that. But let me ask you a question here. What if we don't want to do this skip, like we just select this entire part? What about this? Can we do this?
Yeah.
Yes, maybe. Okay. Think about it. What about we select the entire? If we select the entire block, we know that the software will return some values here. Those are non-decision variables. They will return some value. But what kind of value will they return it? 0 because those are not used anyway. There's no formula here. And they will just, they are not related to any part of the model, okay? So they will just return 0. So if you want to save some time, like say, in this case, it's more like we don't need to select a lot of them, but like in a huge problem, like you have a huge block, this entire spreadsheet, you have those different variables here and there. And you don't want to go select individual cells, you can just select the entire block because you know that it doesn't matter, okay? So we can try, we can just select the entire thing. And then constraints. The only constraint we had is we want all of our net cash flows to be greater than or equal to 0. Okay, we can put a 0 here. That's the only place we said you can put the numerical value in the constraint. Okay, if it's a greater than or equal to 0 constraint. Okay, make them non-negative, linear programming. Okay, so you see as we expected, those are just the zeros. And that's the, no, I don't want to use counting. I want to use gen. Did any of you had an error message?
What were the constraints?
What's the constraint?
Yeah.
This one's greater than or equal to 0. That's the only one. Any of you get an error message?
What's that? Just 0? Or
Greater than or equal to 0. The net cash flow greater than or equal to 0. You got it? Only in A? Most is bigger than mine, so probably it's wrong. Because we want to minimize this one. That's the only constraint. Okay, and because all of it would be okay. Probably some of those would be a very small area.
This one. This time, so it's like, oh, you just started with it? Yeah. I could start over. Well, you can just type it in right now and change it. So with this, so the first page.
Okay. Yes.
Oh, like this one.
Oh, what did they say?
This one. This.
that was great.
What's your,
Okay.
why did nothing change? Okay, your B bar. Never again. I can't give this. It's the first one. Yeah. C-box was right.
Yeah, that's what they
Okay. So then what are you gonna do for that? Okay. Some of J. Yeah, that's.
So, okay, can I have your attention, please? So this problem, I didn't have the, when I said that way, I didn't have the problem, but we do have a problem showing Anna's computer. So what she said is the error message is the linearity conditions required by solver are not satisfied. Okay. Sometimes you will have this error message, the linearity conditions required is not satisfied. It's because of the difference between the values here. Well, look at what's the smallest value on your spreadsheet. 1.8%, right? And the biggest value there is 300,000. So there's a big gap between these two values. Sometimes those big gaps will create a problem for solver. So why?
For some reason, it just puts a little more seed underneath soon as it doesn't put any in the second
So like instead of
Yeah, he wasn't. So it was like long back and wires.
okay, you got the first answer. So that's okay. We'll talk about it next time.
Like all the
So you will remember this clearly. Okay, so okay. If you still have questions, let me know. Otherwise, I'll see you next week. Okay, we use the 5 extra minutes. I'll give them back to you next time. I'll save this one. Yeah.
Well, this apparently solved what